So let's say we have our FillScreen function. And it has the parameters character because we want to fill the screen with a certain character, and position because you want to fill it like half of the screen, the whole thing, or like some position along the screen. So character and position. Then we're in our main function here, and let's say we want to initialize AX with 90. And now we're going to call FillScreen, and the first thing we have to do is we're going to push the parameters onto the stack. So we're going to push character and the position variable. Then we're finally going to call FillScreen. And if FillScreen is located at address 0f 0 0b 0d, then we're now going to set our base pointer register. So because we want to access our variables, move bp sp, and this is the stack when we are in the function at this instruction, and in this instruction, at this instruction. Car is at the bottom. There's position, the character variable, and the position variable, and finally the return address, which is IP instruction pointer and code segment. So once we are finished with this, let's say a few instructions later, we will modify the AX register with the value of the character variable. So that's the byte at BP plus 6. I mean, not the byte, the word at BP plus 6. The word at BB plus 6 because we want the word. And this is AX, so it's going to grab BB plus 6 and the byte after BP plus 6. So once we do that, we're now going to we're going to return. We're going to go back to where we left off. So we're going to return and pop everything off the stack. So when we return, we're going to go to the instruction after the call instruction after this one. So let this instruction here be on this line be compare AX 90. And then the instruction after that should be jump if equal A, and let A be some instruction over here a little after B. So my question to you now is it going to jump to A or is it not? Well, we initialized AX with 90, and then we called our function, right? And then we set our base pointer there, so it's good. And then we want to initialize our AX register with the value of the character with the value of the character variable. Now after we did that, and after we return, everything's popped off. And look where we are right now. We have our AX register with some random value. I haven't even initialized character yet, but let's just say character is has a value that is other than 90. So if that's true, our AX in this function right here is initialized with a value other than 90. Then if it does a comparison instruction right here, obviously AX will not be equal to 90, so it's going to go to B, it's not going to jump to A, but it's going to go to the instructions after the instruction after the jump if equal instruction right here, which is B, which is the address of B right here. So it's going to go to B, and if we want to avoid having these type of problems, we don't want our functions to mess with our registers. So what we can do is we can save AX on the stack. So over here we could add the instruction push AX. So now AX would be on the stack right here, and SP will all of a sudden be here now. SP would be further up the stack. Then when we're finished with that, we want to pop AX. So that we get to restore the value of AX and the stack is finished. We're finished with that, and then we could we could pop all of these variables off the stack and return to this instruction right here with AX finally equaling to 9.